Guys, welcome. This is the first in a series of videos on composition of functions, and although I've put it under advanced pre-calculus, you can learn about composition of functions as early as algebra 1 and maybe earlier if you're very ambitious. Alright, to start our discussion, consider the two functions f of x equals x squared and g of x equaling the exponential 2 to the x. Now the question is, how can we make new functions out of these two functions? Yeah, this is the question. Well, we can add them and make this first new function, and then we can subtract them and we make this second new function, and then we could multiply them and we get this third new function, which by the way is the same as this guy here. Yeah, so we didn't make a fourth new function in looking at this because it's the same as that. And the same is true if we add it in reverse order. We wouldn't make anything new. So far in total, we've got 3 new functions. This guy, and this guy. Yeah? Alright, cool. And we can make a fourth one by dividing them. Now, looking at this fourth new function, it's pretty obvious that if we divide it in reverse order, we'd get a totally new fifth function, right? And that'd be 2 to the x divided by x squared. And that's clearly different from the 4 that we already have here. And the same is true if we subtract in reverse order. We'd make a totally new function. And so using the binary operations plus, minus, times, and divide, we can make a total of six new functions. Yeah? So using these 4 binary operations, we can only make 6 new functions. So if that feels limiting, well, we can do something about it, which is we have a 5th binary operation for functions. And a binary operation is like plus or minus, which is just like a way to combine two things, right? And this time what we're combining are functions. And so for functions, we can add them. And so addition is a binary operation for functions. And same with subtraction and multiplication and division. But there's a 5th binary operation is what I'm telling you. And it's called composition. And using it, we can make 2 additional new functions. One of them is this guy, which is the same as this guy. And then the other is this guy. So the 2 new functions are this here and then this here. Yeah? So in total, if we add this new binary operation called composition, we can make a total of 8 new functions from these 2. Alright, but wait, this is kind of like, what did we do to these 2 original functions to get these 2? Well, here's what we did. This first guy, which again is the same thing as this here using exponent rules, but yeah, we want to look at it in this form. Yeah, this guy is f of g of x, and this second guy is g of f of x. That's how you read this and this. You read them as f of g of x and g of f of x. More on reading them later, but yeah, what we've done to make this here is we took f of x and we plugged in g of x into it. Now, if I had said f of 3, what you do is replace this x with a 3, which would tell you that you have to replace this x here with a 3. And so you'd say f of 3 is 3 squared, or 9. Yeah? And so, it's clear then, f of g of x would be replace this x here with g of x. That is, replace this x here with 2 to the x. But then that means you have to replace this x here with 2 to the x. And as soon as you do, you'd see that f of g of x would have to be 2 to the x squared, which is what I have here. And so that's how you create f of g of x. And for g of f of x here, which is this guy, you plug in f of x into g of x, which means you replace this x here with f of x. That is, you replace this x here with x squared, because f of x is x squared, which means you have to replace this x here with x squared to get 2 to the x squared, which is g of f of x. Yeah? Alright, cool. Let's keep it moving. Alright, now, to summarize, 2 to the x squared is f of g of x, and then 2 to the x squared is g of f of x. And now becomes pretty clear that f of g of x is not equal to g of f of x, because f of g of x, which is this, is the same as that, which is this here. and then g of f of x, which is that there, and these two guys are not the same. It's pretty clear, yeah? And this is in general true, which is that in general, f of g of x is not equal to g of f of x. Said differently, composition of functions, the binary operation composition, is not commutative. And looking at this here and looking at this here, it's not very clear how this guy here, which is composition, and this guy here, composition, are a binary operation. It's not very clear. It's not very revealing, this way of writing composition. It's not very revealing of the fact that composition is a binary operation. So later we'll see a different notation for this here, and therefore a different notation for this here, which will make it a bit more clear that composition is a binary operation, just like plus and minus and so on. Anyway, what we've so far just said around here is that f of g of x is not equal to g of f of x, which means that composition of functions is not a commutative binary operation. All right, cool. Now let's make some room because we need it. What are we gonna say? Of course, there are exceptions to the fact that composition is not commutative. For example, f of g of x will always equal g of f of x if f and g are inverses. And you can check that. Take two functions that are inverses and plug one into the other and then do it in reverse order. You'll see that you get the same result, namely x, right? Okay, that's what you'd get if you did f of g of x and g of x is the inverse of f, right? Okay, cool. All right. And then what do we have? Also, note that, and you've heard me say this multiple times in this video, this here is read as f of g of x. So if I missed any syllables or whatever, now you can catch it all. You can read it. And finally, what I promised, which is I'm going to show you 3 different notations that are typical in many books and classrooms for f of g of x. So it's also denoted by these guys. And looking at this very last version, which sometimes students call fog, it's pretty clear that composition, which is this little o, is a binary operation. So if you don't like this and this doesn't show you that it's a binary operation just like plus and minus, then you can write it in this way. This here means the same as this here. You'd read this as f of g of x. And of course you'd read this also as f of g of x, and likewise with this, yeah? Okay, cool. This is enough for the intro video. Next, I'll prove that composition of functions is associative, although we just said that it's not commutative. And then in 2 other videos, which I might break into multiple parts, I'll give you plenty of examples of composition that would appear on SAT subject tests, yeah? All right, cool. I hope you enjoyed this, and keep watching. Take care.